All right, we're going to talk about subtracting integers and how we just start this whole process of integers. So we've got to ask the question, how are addition and subtraction related? Hopefully, we start to realize there is a relationship between addition and subtraction, because there are opposite relationships all throughout mathematics. We know that the opposite of something positive is something negative. The opposite of something that we multiply, we would divide. So the same is true for adding and subtracting. They're related because they are opposites of each other. And we're going to use this idea of opposites to drive our discussion today about subtracting integers. So if we're thinking of subtracting, we want to think of the words the opposite of. Okay, the opposite of. So let's take a look here at this particular subtraction of two integers. We would say this is 5 minus 3. But I want you to think about it a little differently. Let's see if I can get this here. Okay, I want to talk about it as the opposite of. So if I was to read this, I would say 5 and the opposite of positive 3. So how would I write that? 5 and the opposite of positive 3 is negative 3. So what we're going to say is that when we see the subtraction sign, we're going to say the opposite of, because what that does, it helps us to write an addition problem. And we know how to add integers. So we're going to apply that adding integer concept to subtracting integers by rewriting it. So our rule then becomes, to subtract integers, you need to add the opposite value of the second integer, because that's what we just did, didn't we? We looked at the second integer and we took the opposite value of it. Okay, and we changed to subtract them, you need to add. So we changed a couple of things, right? We changed the subtraction to addition. We took the opposite value of the second one. So we're going to practice this a little bit so that we come to understand it a little bit. Let's talk about opposites. So the opposite of positive 3, negative 3. The opposite of negative 5, positive 5. So we understand what opposites are. Because we understand the opposite value, then it's so easy to come up and drive this home a little bit. But we need a definition before we talk about this rule just a little bit more. So let's take a look here. A definition for the words additive inverse. Now I'm going to give you two different definitions. They mean the exact same thing. One's a little more technical than the other. Okay, so let's look at the first one. The first one says an additive inverse is what you would add to a number to equal 0. So if I was to write down the number 3, what would I add to 3? What number would I put here to make it equal 0? Well, I hope everybody came up with the number negative 3, because if they're opposite of each other, we always stay back where we started, which is 0, right? So when we do that, the other way to think about it is it's the opposite of a number. So the additive inverse is the opposite of a number. So we can say that negative 3 is the additive inverse of positive 3. And the same is true about positive 3. Positive 3 is the additive inverse of negative 3. So using this idea, let's go back to our rule for a second. And if we try to change these words, so instead of saying to subtract integers, you need to add the positive value of the second integer. Let's say to subtract integers, you need to add the additive inverse of the second integer. So this is the technical rule for subtracting integers. And we're going to practice that in a moment, but I want to run some things by you, and let's take a look at it in terms of variables so that this idea is driven home a little bit more. So here I have a minus b. So the rule is we're going to add the opposite. We're going to add the additive inverse. So instead of subtraction, it becomes addition. Instead of positive b, the additive inverse of positive b is negative b. Okay. Once again, here I have a minus negative b. So I want to, instead of calling it a minus sign, I'm going to change it to an addition sign, and I'm going to change a negative b to a positive b. Okay, so remember we were talking about the first screen. I told you we talked about the opposite of. I'm going to take it back there for a second. The opposite of. Well, that's what we're doing here. We're saying A and the opposite of positive B. Well, A and the opposite of positive B is negative B. Here, A and the opposite of negative B. Well, A and remember the words and. The word and means plus, doesn't it? Right? So A and the opposite of negative B, which is positive B. So if we keep that in mind, this opposite of, it probably makes a little bit more sense. So if I'm looking at numbers, here, for example, I have 25 minus 30. That's the way we've learned to look at it. But really, using these words, the opposite of, I have 25 and the opposite of negative of 30, positive 30. So what that does is I'm going to now say I've got 25 and, there's that and sign, right? And the opposite of positive 30, which is negative 30. Now, what we want to be able to do next, after changing it from subtraction to an addition problem using the additive inverse, we want to determine what is the value of this. So we have to remember about adding integers. When the integers are opposite signs, we know that in this particular one there are more negatives than positives, so our answer must be negative, and we have 5 more negatives left over. So 25 plus a negative 30 gives us a value of negative 5. So let's take a look at an example here. Here I have a subtraction problem, and normally you would look at this and say, hey, that's 19 minus negative 4. But we know that's not really how it's read. It's read as 19 and the opposite of negative 4, which is positive 4. So now we can see the change, right? We're going to add the additive inverse. So here we change the subtraction to addition because we want to change, in order to subtract, we're going to add the inverse, right? And then our inverse, instead of negative 4, we're going to have positive 4 because they're inverses of each other. Okay? So now we're going to complete this. 19 plus 4 happens to be 23. Okay, we're going to practice this a couple more times. Let's take a look here. Here in this example, I have negative 33 minus 11. What does that equal? But we have to remember, we're going to change the subtraction problem to an addition problem. So we take this negative 33. This doesn't change. A lot of people just want to grab every negative and change it, but that's not true. Remember, we don't touch that first integer. That first integer stays the same. The rule is we're going to change it to an addition problem, and starting from that change is where we start to change things. So instead of positive 11, we have negative 11. This is the part that changes. Only after, from the sign forward, only that part changes. So now when I look at these integers, I have negative 33 and I have negative 11. They are the same sign. Since they're both negative, we're just putting them together. 33 negatives and 11 negatives all together, I get 44 negatives, so negative 44. I have another example here. 14 minus 46, or really the way that we would read it is 14 and the opposite of positive 46. So 14 and the opposite of positive 46, which is negative 46. Once again, we have opposite signs. So if we have opposite signs, we have to look at it. Which one of these is furthest from 0? Which has the greater absolute value? Negative 46 is further away from 0 than 14, so there's more here, more value here. So we know we're going to end up with more negatives, but we want the difference between these two numbers. So we need to subtract 46 and 14. And we get 32. So our answer then becomes negative 32. The difference of the numbers, there are more negatives than there are positives, or there's a further absolute value. Now, how do we apply this when we have more than two numbers? So let's take a look at this last example, which has 3 integers in it. How do we go about doing that? And we can see it's really just a bunch of subtraction, isn't it? I have negative 200 minus 50 minus negative 10. But again, we're going to read it the way that we've talked about it so far in this lecture. So what we're going to do is we're going to concentrate on the first two numbers. We're going to kind of let this side ride for a second. We're going to concentrate on this so that we can rewrite it. So we're going to rewrite this as an addition problem. So negative 200 stays. The opposite of positive 50 and the opposite of positive 50 is negative 50. So now all we did is we took this here and we've rewritten it there. We okay with that? Now, what we're going to do is take a look at the rest of it. So let's take a look at this part here. Subtracting negative 10. Again, once we want again to go and add the opposite. So instead of subtraction, we're going to have addition. Instead of negative 10, the additive inverse of negative 10 is positive 10. So just like we would do in anything else in order of operations, when we have adding going on, we start left to right. So we're going to start going along that route. So we'll take negative 200 and negative 50. You add those two together, you get negative 250. After I bring that together, now I'm going to add 10. We know that these are opposite signs. These were the same signs, so we can just pull them together. Since these last two are opposite signs, we're going to subtract these two numbers. Well, 250 take away 10 is 240. But since there are more negatives than there are positives, or this is further away, this negative 250 is further away from 0, we're going to have more negatives, so it's negative 240. So hopefully this quick lecture on subtracting integers helps you to be able to change it from a subtracting integer problem to an adding integer problem and be able to move forward from there.